The following content has been provided by RWTH Aachen University.
Just look at this. Does this box have a constant width? What would you say? Who says yes? Who says no? All right. Okay, so I'm adding a couple of more information, and you will do that again. Does this target have constant width? Yes or no? Yes? No? Okay, so what, as we said, the Fitts law predicts the time it takes you to hit a target. And when you're trying to hit something, where would you think the biggest problem or the greatest problem for errors may lie? Is it when I'm hitting something, is it in this direction or is it in this direction? Where would I make more errors? In this, so overshooting or undershooting, right? And this actually, I think Buxton looked at that and looked, well, if I'm starting from, that's interesting. There from position 1 and I'm trying to hit the target, well, it doesn't really matter how high it is because I'm just moving to that side. So the most problem it would be over or undershooting. So the width in this case for the box is this one. While when I'm starting from position 2, then I'm going down, and I tend not to wouldn't move so much left or right, but I would have overshoots and undershoots here. So the effective width of this target is this one. And then the third case, when I'm starting from number 3, well, I'm moving in this direction, so dropping here or dropping here would be more of a problem. So the effective width is more in this area. And that is something that Mackenzie and Buxton, that you can look up where they compared these different ranges there, or what effect did it have, and they found out that it is actually better to measure the width in the direction that you're moving. So for this, it would be this would be the effective width, and you can see this in your everyday computer life as well. So for example, if I have this Windows 10 Explorer open, and I have here my menu bar, and say I'm somewhere here with my mouse and I want to hit this, well, I might overshoot here, and it would take me a little bit longer to reach this target, or it would take a little bit more. If this target would be bigger, I would be able to hit this more easily. It's not much, but well, as I said, this is a brainwashing class. So next time you're trying to click a button and you overshoot, you say, "Well, damn it!" In OS 10, this is a little bit different because in the early days, Apple decided to have the menu bar up here. So once again, if I'm somewhere here and I want to hit the view, for example, how big is this target? Yeah, right, infinitely, because, well, at least on the desktop systems, when you reach the corner of your screen, your mouse doesn't move further away, but it stops at the edge. So effectively, I can just throw my mouse up and say, well, I'm hitting the corner anyways, and tap down. So I have an infinite width there. I can't overshoot at this location. And this actually shows that some toolbars are very evil, because when you leave one tiny pixel to the edge of the screen, which I think Photoshop had implemented in one of their versions, where they had this border around that. Well, and you go up and you hit, and you're not selecting there because you're in this one pixel that is not doesn't belong to the menu, and that is quite frustrating. But yeah, this is one of the applications where you can realize how this is in place in the real systems we have.
This content was provided by RWTH Aachen University.